Hello, my name is Matthew Muir, and I will be discussing the process of my design studio thus far in relation to pedestrian volumes. For me, the development of this project started with trying to find a meaningful relationship of data between the Bay and the city of San Francisco, as outlined in our studio design problem. From the start, I couldn't seem to find a relationship that made much sense parametrically. The data that I collected on views versus building height or population density versus open space didn't seem to address the Bay directly. The truth is, none of these systems seemed all that interesting to me because most have already been done in some way. As a result, my strategy for narrowing the possibilities has been first to focus on just one data set. In this case, pedestrian traffic volumes provided by San Francisco Municipal Transportation Agency, or SFMTA for short. This seemed appropriate given our site, the Embarcadero. Second, by creating the sections along the stretch of the site. At first glance, the data collected from the SFMTA appeared to be a strong movement in the right direction, but was essentially a one-dimensional value of volume and not very parametric. I needed a second value to compare or parameterize with. The easy solution would take some arbitrary value from, say, the Bay views between the piers, and then make a deduction of what the parametric system might mean. Instead, I've actually been more interested in to see if there's what other hidden values there are in the linear data of pedestrian volumes. This is kind of like seeing a demographic of population. There's the number of people, but there's also a lot of hidden information like race, sex, age, and others. From the notes I took in the group site visits, I recorded people on the sidewalk and their activities. Most of the data I collected about their activities were just people walking. But where are they walking to? Is it home, work? Do they have a destination? Do the joggers follow some loop? The same could be said about the pedestrian demographic, which is what led me to assign three primary pedestrian typologies. First, the commuter, who's the man traveling from work to home, or vice versa. Second is the spectator or tourist. He's the one looking at all the sights. And then the third is the jogger. Like a standard demographic, each of the pedestrian typologies have unique qualities that define them. In this case, I tried to imagine what path they might take or prefer as their unique quality. The commuter is ideally going to want the shortest distance from point A to point B, or work to home. The spectator would probably meander, being attracted to many different points in the city. And the jogger would want to maximize distance traveled without getting too far from point A, with no real necessarily destination. This information is all very interesting, but doesn't really set up a parametric for me. So I expanded the typologies to relate to existing building program along the site. My strategy for this was to define one primary program that each pedestrian typology might seek or use along a path. For the commuter, this would be things like public transportation hubs, or for the spectator, attractions. Maybe for the jogger, it's a park. To keep the data manageable, I created one continuous path through the series of the site section at preferential states. To accomplish this, I first applied a value of 1 to each pedestrian typology program and mapped them in each section. Then I simply summed up the numbers of each type in the section, and whichever one had the most associative program gained, created a preferential state over the section. This led to many possible iterations for the quote-unquote path. For this iteration, let's call it path version 1. I just drag and drop the pedestrian typology diagram into the section and connected them. For version 2, I reasoned that I could just use the program's existing position as points and draw a line through these points and sections, helping to relate it closer to the site. Path 3 is becoming version 3 is becoming a bit more complicated and a bit more parametric by attempting to achieve an optimum position for the program point as it relates to pedestrian volumes within each site section. In short, I'm first defining the preferred typology for each section as already described, mapping the centroid of the highest pedestrian volumes through a Voronoi diagram, and then analyzing the distance between the program points and the centroid of the Voronoi. My assumption is the shorter the distance, the more pedestrian volume to move through that program point. In conclusion, I'm not really sure where this is all headed. In the end, I imagine it might end up being some elevated path like the High Line or for San Francisco, or smaller scale like an elevated street crossings to more efficiently move people. In any case, as of now, I'm more concerned with the validity of a parametric and the data and less about what it looks like. Any feedback or ideas would greatly be appreciated. You can contact me at mattheww.muir@gmail.com or through our studio Facebook page, LAN MSU, Montana State University. Till then, cheers.